Okay, so you have, let's look at this top part here first, the parts of an expression, okay? So I don't know how much y'all have done it in your classroom. I think y'all have done it quite a bit. Um, Guys, hey, can we kind of be quiet a little bit back there? Can we quiet down a little bit or a lot? How about that? Thank you. Okay, so parts of an expression. So what's the difference between an equation and an expression? Have y'all went over that?
No, I don't think so.
Okay, so an equation, what's the root word of equation?
Problem.
No, equal. Equal, okay? So an equation has an equal sign in it. An expression does not. So what we all been going over in class should be an expressions, right? Okay, all right, so some vocabulary words that we need to know. Term, well, lot terms. Lot terms. Carson, hand me that, one of those purple sheets, please. Right here, on the stool. Thank you. Okay. So y'all familiar with these words, right?
Basis. Yes. Coefficient.
Okay. Mm-hmm. Constants. Okay. Constants, yes. Okay. All right. So a few things to kind of help you remember things. Okay. All right. So if we've got 4g plus 6g plus 7 squared plus 5. Okay, that back group. You're fixing to make everybody have to go silent. Your choice, of course. Okay, your choice. Okay, all right. So now we know what terms are, correct?
Yes.
Okay. Who wants to give me a definition of term? What a term is? Not a lot term, but a term. Tell me.
A signed number, a variable, or constant multiplied by a variable or variables.
That's a term?
Yeah.
Okay, all right. So that's not necessarily my definition of it. So what are the terms up here?
4G and 60.
Okay, so technically these all are terms. They're all terms. Okay, this is a numeric term. Why was that numeric for?
Because it only has a number.
Number. Okay, so that's what numeric means is number. Okay, all right. So this is an algebraic term. Why is that algebraic?
It has algebra in it.
It has
The letter.
It's got a variable in it. Okay, so this is algebraic. Why?
Because it has letter.
Variable.
Variable.
Okay. All right. So terms are either numeric or algebraic, and they're separated by either a plus sign or a subtraction sign. Okay. So if you've got something, that's the 20th time things around. Hello. Uh-huh. Okay. Right. Yes. All right. All right. James, come here. James, where you at? Oh, come here. Come here. Get Xavion's stuff. And his phone is in his desk. Can you take it to the nurse's office? Thank you. Okay, so terms. So you can have numeric terms, 2 plus 2 minus 3 plus 4. That's a numerical expression, okay? Because it's all numbers. It's a number expression, okay? This is an algebraic expression because it's got a mixture, okay? You got some constants, but you got some algebraic, okay? Okay, so any questions about numeric algebraic?
Nope.
Okay? Yeah. If you don't understand something, make sure you speak up, okay? Okay. I don't know how y'all do it in there, but don't be afraid of me. Don't be worried about me. Just be yourself, okay? All right, well, I shouldn't erase that. All right, 4g squared plus 6g plus 7 squared plus 5. Okay, so 3g squared. Okay, all right. So the lot terms. Okay, lot terms. What are the lot terms in this?
Wouldn't it be like 2,
Those are the
7?
same.
Okay, so lot terms are terms that are a lot. Okay, all right. So terms. Go ahead. I'm sorry. Go ahead.
So like 4g 2 and
4g squared.
Yeah.
4g squared.
And 3g squared.
3g squared. Okay. Are there any other lot terms?
6G?
No.
Would
Okay.
6G be in it?
Okay. With 6g being it, guys?
No, 'cause
No,
it
I
doesn't
don't
have a
think so.
square.
Okay, yeah. So it's got to be the same variable to the same power. Okay. Now if that was squared, it would be okay, but that's just to the first power. Okay. That's to the second power, so they're going to be different. Okay. All right. Oh. I need to set my timer. Okay. All right. So are there any other lot terms?
No.
Okay. What about our constants? Can we combine? Are those lot terms? Tell me tomorrow. Okay. Tell me tomorrow if 7 squared and 5 are lot terms tomorrow. Okay. Y'all got a pencil with you?
No.
Okay. So fine if you don't. But hey, a good idea is to bring a pencil from now on. Okay. All right. So bases. What are bases? So let's go around. I'm sorry I don't know everybody's name. Okay. Haley.
Sam.
Sam.
Natalie.
Natalie.
Alton.
Alton. Even though you got Tommy on your shirt. Oh, that's not your name, is it? And then Kendall, right? Wow. It's a joke. All right. Bases. What are the bases? Anybody?
Isn't it like the 6g? Is it? No. Isn't it like 5?
Yeah, it's like 5. I think.
Wait.
'Cause it's just a base number by itself.
No. It's.
Would it not be the numbers?
Would it not be the numbers?
Is it 7
Not necessarily. Huh?
Is it 7 2?
7 2? You mean 7 squared?
Yeah.
That's one of them. Okay. This is, so when it's got a power, there's a base. Okay? That's got a power, right? So there's a base. Okay. Are there any other bases?
5.
I,
Is it 5?
5.
3g.
What's the power to 5?
There is.
It doesn't have any.
It doesn't.
So when it doesn't have one, it's understood it's 1. Okay? So this is like 6g to the first power. This is 5 to the first power. Okay? So if it doesn't have anything, it's the first power. Just understood. Okay? So are there any other bases?
Could it be 3g to the second square?
Well, the G, because that's the base to that.
So the
I see.
So, yeah, that
6
would
and 4.
6 and 4.
Yeah, with those stuff count. Or
It's
do-
got to have a power to it.
Yeah, so 4 would count as well.
But it'd only be g and the
There's another G, so you can say G again if you want to. I don't know how Miss Tabor's gonna handle that, but
so
that's a base to that power. That's a base to that power. That's the base to that power. Okay. Is there any other bases?
No.
Okay. Variables. Jesse, put your mask on.
Is it 5?
Huh?
Is it 5?
A variable? So what is a variable? So let's look on our paper there and tell. Does it say tell us what a variable is there?
No.
Oh, rats. I thought I had
this
a little bit
is
of
the
stuff on it.
4, the 6, and the 3.
The variables?
Yes.
Okay.
Or no, it's just the 6.
So what's the root word of the word variables?
Where?
Vary. Okay? The word vary. What does the word vary mean? It's not this word. It's not vary with the E. It's vary with an A. What does that word mean?
I don't know.
Like spell. Change. Okay? Something's variable. Y'all ever listen to the weather and they say the winds are light and variable?
No.
No.
I mean, I've watched the news, but I
Okay.
never heard
So y'all watch the news forecast sometimes. The weather part of it? Even on the radio, going down the road or something, ever so often the weatherman comes on the radio and they'll say so and so, the temperature's gonna be so and so, and the winds are gonna be light and variable. Means they're gonna be light. They're gonna be changing. Okay, so variable, like a vary, means to move around, to change. Okay, so we don't know what G is, do we? We don't know what G is. It could be subject to change. Okay, depends on what a word problem or what a problem says it's going to be. Okay, all right. So the word variable, root word is vary. It means to change. Okay, so what are my variables? G. And again, I don't know if she wants to do this or not, but you got three variables. G squared, G, and G squared again. I don't know how she wants to do that. We haven't actually talked about it. We'll talk about it. But technically, you've got the G's there, okay? You got one that's G squared, so I don't know how she wants to approach that, but we'll talk about that, okay? All right, coefficients. What is a coefficient?
A consistent multiplied by a variable or variables.
Okay, so in English, what does that mean? Like in everyday words, what does that mean? Coefficient. Anybody? Okay, so listen here. This is like the more math definition of, okay? It's the numerical term of an algebraic, I'm sorry, let me rewind. Rewind. It's the numeric part of an algebraic term. Okay? The numeric part of an algebraic term. So what does that tell you?
That it's kind of like that, but it's translated.
The numeric part of an algebraic term. So this is an algebraic term.
So the number.
Yes. So what is it? What are my coefficients?
4, 6, and 3.
Good. It's the number part of each algebraic term. The numeric part of an algebraic term. Algebraic. Okay? It's the numeric part. It's the number part. Okay? That makes sense?
Yes.
Okay? This is your coefficient. This is your variable. This is your power or exponent. Power, exponent, some people call them different things, but they're the same thing. Power and exponent, same thing, okay? All right. Now, I don't know why I put variable twice, but what's the one that we're missing?
Constant. Degree.
It's constant. Excuse me. No, I got them. Basis, coefficients, exponents. Oh, there it is. Exponents. Okay. All right. So what are my exponents?
2.
So there's 3, and then again, I don't know how she wants. We'll have to talk about that because 2's the same one on each one of them, but we'll see. We'll see. Okay. What are the constants? So what is a constant?
Isn't it
Like
a
the
number
5.
with a letter?
What now?
Like a number with a letter?
No, that's the number
Like-
with a letter. That's
the one
a
that's by
coefficient.
Is it one that's by itself?
So it'd be 5.
Not necessarily, because you could have this
Like it doesn't
as an
change.
algebraic expression. That's by itself. That's by itself. Okay. So what does the word in general constant mean? What does the word constant mean?
Over and over again?
Yes, it means it's the same thing. Okay. How much is 7 squared always going to be?
7.
How much is it? How much is 7 squared? Do you know what 7
2.
squared means?
Oh,
2.
like 7 times 7?
What's that?
49.
Okay. So how much is 5 always going to be?
5.
Okay. They're constantly going to be that number. Okay? Your numbers are not going to change. 5 is always 5, 10 is always 10, 11 is always 11. Okay? Those are constants. But then you have variables can change. So if you have something like 4G, let's do it. If G is 3, 4G, 4 times 3, that's 12. However, if we decide G is 4G, 4 times 4, which is 16. So you see, depending on how much G is, your end result changes.
Yeah,
Right? So
the
that can vary. Yes. Okay? However, 5 is always going to be 5, 49 is always going to be 49. Make sense?
Yes.
Okay. All right, well, there's the thing.